Welcome to the Rotary Club of London's meeting of Monday, August the 8th. For your information, August is Rotary's membership and new club development month. So I encourage all of our members to bring out and introduce new people to Rotary at our meetings. And it would be nice, we have a meeting coming up in person on Monday, August the 22nd, where we are hosted by the Highland Golf and Country Club. Now I'd like to turn this over to Malcolm Cox, who will introduce our guest speaker for today's meeting.
Thank you, President Rick. I'm happy to introduce our speaker today, Dr. Jennifer Mather, who's online all the way from Lethbridge, Alberta. Jennifer has a BSc in biology from Florida State University, and she got that in 1972, and a PhD in psychology from Brandeis University in Boston in 1978. She was a research assistant professor position at Western here from 80 to 85. And Jennifer's published many articles on cephalopod behavior and intelligence and is regarded as an authority on ethics with regard to cephalopods. She's been studying octopuses for more than 40 years, and she found this love of sea life while growing up in Victoria, British Columbia. It was because of this that Jennifer was asked by South African filmmaker Craig Foster to work on the Netflix documentary My Octopus Teacher as a scientific consultant for post-production. This was a documentary film 10 years in the making, and it won the Oscar for Best Documentary in 2021 on April 27th. So with that, please welcome Dr. Jennifer Mather. Jennifer.
Thanks for inviting me, Malcolm. It's an interesting place to be. As you said, many, many years ago, I was in London, but it has been many years ago. And I'm not quite sure how you traced me down, but it's fun to be with you. I would say, actually, that while octopuses look like something completely exotic for anybody in London, or for that matter, in Lethbridge, I could say there are two lessons you can get out of this presentation. The first one is pretty simple, and you know it already. Don't believe everything you hear. And the second one is, nonetheless, don't be afraid of new ideas. This, by the way, is not how octopuses usually look. Somebody's dropped an octopus in the water where they are usually is crawling around on the bottom. But I had heard little bits of hints about the idea of octopuses and aliens from space. I thought it was all social media. And I really don't listen to social media. So it wasn't until the Astronomy Society said, "Can you talk about this?" I thought, well, okay, sure. That's a far-fetched idea. But it turns out there were some scientists who suggested it. It was proposed by a group mostly of cosmologists. There they are, and there's their paper. There are actually 33 of them. And their idea was that octopuses came from space, you see this at the bottom of the slide, kind of in comets, which really is very far-fetched because comets burn up on the way to Earth. And I thought, why would they bother to say that? So I took a look at their evidence. First of all, they said this is what evolution is. Nautiluses gave rise to squid and then to octopuses. Second, and probably their most important point, is they said there's no fossil record. This transition can't have happened because we can't see any traces of it. Then they said that modern cephalopods can alter their DNA, which is true, but so what? We'll get to that. And then the fourth one is that octopuses are smart and they're different. Yeah, does that prove they came from space? So I'll take these things in one at a time. Next slide, I'll get number one. They've got the wrong evolutionary route. Now, that doesn't mean it couldn't have happened, but still I get kind of suspicious. Next. Squid are not octopus ancestors. Next. Here's actually the phylogenetic tree based on present animals. And you see the nautiloids have nothing to do with the coleoids particularly. And the octopuses and the squid and cuttlefish are different branches. Next. What about no evidence of evolution? Well, nautilus fossils and also belemnoids and ammonoids in fact, were very, very abundant in the past. They dominated the seas. But fossils are easy to see if it's been a solid substance, if it's been a bone, if it's been a shell, they're in the fossil record. But squid and octopuses don't have any shells, so they have teeny little shells in the interior. So of course we can't see them in the fossil record because soft tissues don't fossilize. So that's a bad argument. Next. I think you can give one more return too. It's true that coleoids can edit their RNA, and this is a nice metabolic trick, and it is probably very useful for plasticity, but it doesn't mean they came from space. Next slide. And this, yes, of course. Yeah, octopuses are smart. So why should that be a problem? Well, presently we're working on a model of evolution called the social hypothesis, which says that we and our primate relatives in particular have had the pressure to solve social but not ecological problems. And that is from the solving social problems that high intelligence evolved. And then you have a complex of big brains, long life, parental care, complex societies, leading to, of course, us. Next slide. Okay, let's have all those pieces, two more. So why is it that we, what I would describe as otherwise intelligent human beings, decide that octopuses are smart and they couldn't be smart, so they must have come from space? It actually goes back to Aristotle, because Aristotle devised what he called the scala naturae. And this is how he felt evolution worked. Evolution went from trees to shellfish to birds to humans, who of course were the center of the universe, and to angels. It's not true. We know it's not true. But somehow or other, it has seeped into the history of Western civilization. So you find Christianity saying that man has dominion over the earth. And this has been very bad for the earth, by the way. And Descartes, who was one of the early philosophers, who said that animals were just automata, humans had souls, humans were special, we could do what we liked to the earth and to the animals. So we've ended up being what I call anthropocentric. And so the octopus doesn't fit anthropocentrism. Next slide. This is what's really going on with the evolution of animals. So we're over there in the chordates, and the cephalopods are center with the mollusks. Evolution's gone in many, many different directions, generated many, many specializations, and we're only one of them. Next. Okay, do I have any trouble saying that octopuses are intelligent? I don't have enough time to tell you how, but yes, they're extremely intelligent. Anti-predator tactics, they've got a lot of predators. They've had to figure out how to evade a lot of them that use a lot of different strategies. They've also had to figure out how to eat a bunch of different species. So they've also had to develop different foraging strategies. And anytime that people have studied these animals and tried to get them to learn, except for social transmission of learning, they're just tremendously successful. Habituation, associative learning, spatial memory, you name it, they can do what you like. Now, in a more practical sense, they're tool users. And it's really interesting that they use a jet of water through their flexible siphon as a tool. They use it to clean out the homes they're going to hide in. They use it to move things across the landscape. They use it to repel scavenging fish. One of my favorite examples of their tool use was at the Seattle Aquarium. There was an octopus there who didn't like the night light that was on for 24 hours a day. So it directed its siphon up towards it, shot a jet of water at the light and shorted it out. And there it was, and solved the problem. They're also much more like humans and what we would call higher mammals in the sense that they're very, very exploratory. Of course, if you've got 8 arms with suction cups along each of them, it's absolutely no problem whatsoever to explore. And my colleague Roland and Anderson and I found that they also play. And what we have been doing, we put octopuses in a fairly barren tank in the Seattle Aquarium, and we provided them with a floating pill bottle. And a couple of the animals, well, of course, one of the things we hadn't planned is the octopus was at one end of the aquarium, and the water intake was at the other end of the aquarium. So the bottle sort of bounced along the water intake and came down towards the octopuses. And of the 6 animals, 2 of them shot a jet of water at it so that it went back to the water intake. And then it came slowly back to them, and then they shot another jet of water. Now, once or twice wouldn't do it, but one of them did it 16 times. And I always remember because Roland phoned me. This was before email was so flourishing. I said, she's bouncing the ball. And it's true. She was doing the marine equivalent of bouncing the ball. Next slide. Okay, so if we say, are they really a different model for the evolution of intelligence? By mammalian standards, actually, they have big brains. And not only that, they have an area in the vertical lobe that's like our frontal cortex, which is the organizing area. So in that sense, structurally, they have similar organization within their brains to control their behavior. However, they fall down like crazy if you think about long lifespan. You know, we have this saying, elephants never forget, and it's the elephant matriarch that remembers where the water hole was, that they haven't visited in something like 20 years. But octopuses have a short lifespan. The average is about a year. And even the giant Pacific octopus only lives 2 to 4 years. So the question is, wait a minute, they don't have a long lifespan. They don't have a lot of time to use the things that they're going to gather information about. The third thing that really doesn't fit them to the social model, of course, is that octopuses are mostly solitary. There's a couple of species that don't seem to be. We don't know enough about them. They're also cannibals. They're not really systematically eating one another. It's just, you know, occasionally if the opportunity arises. It's pretty difficult to socialize with somebody who might eat you, no question. The other thing that's interesting about this is that they really have a different control model. And it's famously true that they have 3/5 of the neurons of their body in the arms and a lot of decentralized control. In fact, I've got a diagram for that. Next slide. Now, this is where the myth arose. Hello, can we go back to the diagram? Good, thanks. That the brain gives general commands to the arms, and that the arms carry out subroutines. And in fact, the arms have a chain of ganglia down the dorsal surface, and each ganglion controls one sucker. The suckers have touch receptors and chemical receptors, and muscles controlling them, of course. And they can do a lot without having to have the central brain telling them precisely what the details are of what they can do. I was thinking of this in a sort of a general sense. And if you think about Putin as the human model where the brain controls everything, and then you think of our federal government as the octopus model, where there's general commands for what to do, and then the ministers get the people, the deputy ministers, and they have people carrying out things. And in general, the prime minister doesn't know everything about all the little details, and that's more like the octopus model. Whereas, though I'm not really familiar with what he's doing, Putin tries to keep touch with absolutely everything. Now, there's another rumor that arose, of course, from the octopus that the brain didn't know what the arms are doing, and that's not true. Then there's this horrible thing that I get on the web that says something appalling, like the animal has 9 brains, 1 in each arm and 1 in the center. No, 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 no. Next slide. So why would they have evolved this particular control system and this particular high intelligence? Well, they're in really, really, really complex and changing environments near shore. And they need to keep track of this environment. They don't have any shell to hide in. They have to be living by their wits. They don't have any spines. They don't have any repellents. They don't have any shell. I think there's one more slide there. One more entry, 1 click. And about the time the octopuses were evolving, nope, it doesn't. Do you mind going back? The bony fishes were also evolving. And in fact, what probably happened is the fish are long-lived and they don't reproduce through, say, 10 years. Meanwhile, if you think about it, the cephalopods have reproduced about 4 or 5 times. So in this sense, they've had a different model of evolution. That doesn't mean that evolution hasn't caused them to have that model. In fact, it has. Next slide. Okay, I'll have all 4 of these come in. What this made me think about is not so much, oh, of course, people say, well, the social model of intelligence, that's the one that matters. And that's not the one that matters. Does that mean that the octopus is going to tell us what extraterrestrial intelligence looks like? Probably not. Because they evolved on Earth and the constraints of Earth. But what I found interesting is that it makes us have to take away the narrow assumption that the social model of intelligence is the only one, and that we are the pinnacle of evolution, and that we should take ourselves seriously as the center of the Earth. It lets us say, hey, wait a minute, there's other ways to evolve intelligence. And once you've got 2, you can think of 3 or 4 or more. And one of the things I'm finding fascinating to think about is the social insects. See, one of the problems is, even though invertebrates are 99% of the animals on the planet, we don't really know how most of them work. But the social insects look like a very interesting case. They have a lot of pre-programming, but they also have a lot of learning. And I think that's the second lesson I wanted you to have, that we've been too careful to follow the model that we first thought up. And we have to take a deep breath and say, well, okay, there are other models of intelligence out there, and we should look at them, not kind of decide that they came from space. Next slide. By the way, when I was doing this for the astronomers, I thought, boy, if you want real aliens, I should go look at some of the animals in the deep. So I got a couple of pictures of animals of the deep here. I swear the people who are looking for models for horror movies about aliens, they should go to the deep and look at some of the physical manifestations they can get there. They're absolutely fascinating, and I love looking at all these pictures. Okay, thanks very much. And I do have time for questions.
If you could use, you can either put your hand up or use the raised hand function. Jan has got hers up. You go ahead, Jan.
Yes, doctor, I'm interested in the reproduction of octopuses. How often do they have children? How many do they have?
They reproduce at the end of their lifespan. Okay, so what that means is an octopus, a female octopus will lay somewhere between 100 and tens of thousands of eggs. She will tend them and care for them, and when they hatch, she'll die. Gotcha.
Gives a new concept to parenthood.
Think of it as a Big Bang theory of reproduction.
You have no longer have any responsibility for your progeny.
Yeah, I mean, it's true she tends the eggs. And by the way, with squid and cuttlefish, they don't even tend the eggs.
Oh,
They mate and die, and the eggs grow up, hatch. That's one of the problems that people who want to raise these animals in captivity have to deal with. Because, for instance, a giant Pacific octopus, which is a really sizable animal, has eggs the size of a rice grain.
Hmm.
And when the eggs hatch, they hatch as paralarvae. They're not exactly like the adults, sort of similar. And they drift off in the plankton, and they live in the open ocean for about 6 months before they come down to the bottom, at that point a few centimeters long, and then live the way the adults do. So in terms of raising animals, one of the physical difficulties is how do you feed rice grain sized animals who have completely different mode of life from the adults? And so far it has defeated people.
Malcolm, did you have a question?
Yeah, I was going to comment on one thing when I'd mentioned earlier that Jennifer consulted on My Octopus Teacher. If you haven't seen this film, I think it's still running on Netflix. You need to check. But there is, of course, we talk about the life and death of the octopus. And in the end, the female that it is with him, there's some really interesting scenes. The octopus actually, after all this time, comes to his hands, sits on his chest. He has it holding against him with his chest. So you got to say there's sure got to be a connection going on there. And then the female that he studies for some time lays all her eggs, and then she dies, and this becomes food for the other fish. So it's a really, really good film to watch, and I do recommend it highly. So that's my comment. That's how I connected with Jennifer to start with, watching that, and then the story in the Globe and Mail. So. Okay, any more? Should be lots of questions about this subject. It's a great topic.
Jim?
This isn't particularly about the octopus, but you mentioned, Jennifer, that you didn't watch social media, but there seems to be a lesson here about misinformation that's out there on social media concerning the octopus and the way to counter it. Do you continue to run into this idea that these are aliens, and your methodology for countering it, besides speaking to groups like us?
Yes. The difficulty is, you see, I'm centered in science. So most of the colleagues that I talked to about this idea went, oh, come on, you've got to be kidding. And the difficulty is there's so many people who use social media who have no contact with the reality. And of course, why would they? You know, I don't know what we do about this proliferation of social media, this passage of information from person to person that's completely false. Jim, if you have any idea, love to hear it.
Anybody else have a question for Jennifer?
Yes.
Don.
I'm not even sure how to phrase that. So with the intelligence in squids and octopi, yeah, I'm not even going to try. Is there any relationship with the size? Like, for example, there are giant squid and larger octopi, and then there are the smaller ones. Is there any relationship between the intelligence and the size of the squid?
Okay, well, nobody's really looked at that. But because I have actually worked with the giant Pacific octopus, and I have worked with the common European octopus and the common Caribbean octopus, which are about 1/3 its size, and the pygmy octopus, which is about this big, I would say no. On the other hand, it's really hard to correlate. We just don't have enough information. In fact, Octopus vulgaris, the common octopus in the Mediterranean, is in some ways the most up-and-coming, exploratory, strong personality, interesting species. Okay, it's possible that those that are naturally nocturnal may be less intelligent than those that are naturally diurnal, but I think that may be because we're diurnal and we study them in the daytime. So I'd say no, there's no real correlation. On the other hand, by the time you get to a little teeny octopus, I don't know how much it's got scope to do, but the biggest isn't the smartest that I can see. Be nice if it was, but there we go.
I have one other question.
Yeah, yes.
And it relates to the business of the octopus's brain sending signals to the appendages, and then the appendages carrying them out. Is there any evidence that the same sort of thing happens within us, that we send out commands that then the rest of the organ takes over, that there's intelligence in some of our organs beyond what we are conscious of?
Actually, yes, that's a good point, because we completely underestimate the kind of coordination that our spinal cord does. We used to, because, we used to say, well, these things happen at a reflex level and we have no judgment about that. But in fact, it turns out there are some programs in the spine. We don't really know enough about that. But there is a big difference, by the way, because let's imagine that you chop an arm off an octopus and you have it on a moist surface. Well, it will crawl down the moist surface. And I can absolutely guarantee you that I chop your arm off, it would not reach out and pick up something. So quantitatively, it's really different. But there are things going on in the spine, and the more we study them, the more we see that the spine is doing a fair amount of processing. Good question, Jim.
Well, I was just wondering if the results of the studies of the octopus has led to further study of this phenomena within our own bodies then.
Do you know, I don't know why we don't take lessons from the invertebrates, because there are so many things that they can do that we would certainly like to know how they do it. For instance, if they lose an arm, they will regrow it. And boy, if we could regrow an arm, we would be really doing well. So I don't know why the scientists aren't studying more about the kinds of things that animals that are totally unrelated to us can do that we can't do. And this editing RNA is interesting, because what it means, the way that we usually inherit variation is the DNA, which is then passed on to our children and our grandchildren. But if we knew more about how we edited the RNA is the messenger to the cells and the organs. So for instance, let's imagine that you were going to go work in Antarctica for a season. If you could edit your RNA so that you would be more tolerant of the cold, and then when you came back from Antarctica, you lost that, it would be a very interesting ability. But as I said, as far as I know, nobody has figured out how to study these things really well. That help?
Yeah.
There's so much potential in the invertebrates. Think of it this way. They are 99% of the animals on the planet. And yet we barely know them. they estimate, I think for the insects, they estimate we know about 2/3 of the species, and we haven't even identified the species of the other 1/3. And they get down to the bacteria and they say, well, maybe if we're lucky, we know about 1/10 of them. And you look in places like the deep ocean, and it's, as I said, the deep ocean is just completely unknown.
Hmm.
They've got ROVs now, remote operated vehicles, going down, and in fact, NOAA, the atmospheric and ocean science branch in the US, actually sends ROVs down and it films what they've got. And they keep finding new species. You know, they've got this thing's puttering along, taking pictures inside these. And I can remember I was watching one of these things. They said, hey, there's something over there. It looks like an octopus. And they directed the ROV towards it and they shone the light on it. And I went, I don't know that species. And the next thing, one of their advisors said, you know what? That's a new octopus species. I think it wasn't just a new species, it was a new genus. And when we get in places like the open ocean, we get in places like the top of the rainforest, we discover whole worlds we knew nothing about. It's exciting, but sometimes it's frustrating knowing that there's so much we don't know. And I have to say, worrying about the fact that we're wiping it out.
We have time for another question if anybody has one. Jan, need to unmute.
Yeah. Doctor, do octopus only live in salt water?
Yes. How do I put it? The mollusk metabolism is not as good as the vertebrate metabolism. And one of the big things, interestingly enough, is we have hemoglobin in our blood to attach to oxygen and take it around the body, right? And the mollusks have hemocyanin. Now the hemoglobin has an iron molecule in the middle of it, and the hemocyanin has a copper molecule, and I am not a physiologist, but it's less efficient. So in fact, the octopus has actually jacked up the efficiency of the mollusk about as far as you can go. And it's not likely to adapt to move into freshwater, to move into the land, because it's really pushing the envelope in terms of its physiology. Okay. In fact, it has 3 hearts. It's got 2 accessory hearts that pump the blood out to the gills. So they're going to stay marine, unfortunately. It would be lovely to imagine that they would evolve onto land, but there's no chance of that. We'll just have to keep watching them in the ocean. Thanks, Malcolm.
It's my pleasure, Dr. Mather, to thank you for your most illuminating presentation. I'm not sure whether I would have liked them being aliens or from our planet. Would have been exciting to be able to say we do live amongst aliens. We maybe do, but we just don't know them. Any event, in recognition of your presentation today, the Rotary Club of London has made a contribution to the Polio Plus campaign of the Rotary Foundation to immunize 50 infants against polio. Because of you, Rotary is one step closer to a polio-free world.
Thank you, Rick. That's very worthy donation, and I'm very pleased that you're doing that.
Now we have announcements. Keith Morrow, do you want to make an announcement about bingo?
Yes. So on the 31st, Sunday the 31st, we staffed a bingo. There were 106 participant players, and we made a deposit to the pool of funds of $5,830. And Keith, Jack, and Jerry were the Rotary members working that bingo that night.
Thank you. You also want to make an announcement about the email you just sent out regarding making payments and passwords and that?
Yes. So via Club Runner email to all members, we sent out a blast indicating that it is no longer necessary to enter the password requirement when doing an e-transfer. We've set it up that it'll be directly deposited to, if you are using the designated email account, to our operating account. So it'll only be necessary for you to enter my dues or my donation or my fines, but there's no password requirement anymore. In fact, when we did a test run on the Bank of Montreal format, there wasn't even an option to enter password because of the direct deposit for, option now being selected. So that'll make it a lot easier for members on an administrative basis to transfer money to the club.
Thank you, Keith. Randy Harden.
Yes, I'm happy to report that our next youth exchange student arriving from Switzerland will arrive on August the 24th. Her name is Nanda, and the last name is spelled J-U-R-T. So I'm inclined to say Jurt, but of course that's not correct. She is German, and so that should be Yurt. So I will mess up, I'm sure, regularly every time I look at her name, but it's Nanda Yurt. In any event, she will have 3 host families, Ian Davies and his wife, Harry and Kathleen, and then Dawn and Brenda Fraser from the Rotary Club of Southern London. I would urge everyone to connect with Nanda when she arrives. And if you have any family events that you think that she would enjoy, by all means, please invite her. Now, her first week from August the 26th to September 3rd, she'll actually be up at the cottage with the Davies. So you won't be able to really connect with her at that point. She'll be going to Saunders Secondary School. And we have started the registration process there. So by all means, we will have her at the next in-person meeting in September. So Nanda speaks French, German, English, some Latin. She's a very bright girl, very sporty, and very involved in the arts as well. Plays the German flute. You'll have to look that up. So, anyways, that's all I have to say at this point in time.
Thank you, Randy. I'm going to make an announcement on behalf of Diane Twinstra. She has lined up 2 London Food Bank service opportunities for our club. They are on Monday evenings that do not coincide with our Monday meetings. So the first one will be August the 15th. There's no Rotary Club meeting that day. So it's a good opportunity for us to do some service work in our community. The next one is going to be on Monday, September the 19th. She needs about 10 volunteers. So if you're available on those evenings, it would be appreciated if you would get in touch with Diane and provide her with your particulars and that you're prepared to work. And we do more service in our community. And it's a very worthwhile cause, especially nowadays when so many people are suffering from challenges of being able to feed their families, etc. I think that's it. There's one other one here that Dawn has posted. The Satellite Club park cleanup has been rescheduled to Tuesday, August the 16th at 6:30 p.m. at the Cavendish Park, weather permitting. We should pay attention to the Satellite Club's scheduling of this project if we want to know what we want to do, if it's going to be a good weather day. But hopefully they'll be able to get it done on August 16th. And they welcome all participation. And it basically doesn't last much longer than an hour, if that. And then they always adjourn for some fellowship and beverages somewhere. Do you want to add anything else to that, Don?
No, that's about right. There's beverages afterwards.
Okay. August the 15th is no meeting, but there is the London Food Bank service project that we'd like to have staffed. August 22nd is our next in-person dinner meeting, and it's at the Highland Golf and Country Club. I remind everybody that there will be an email come out from Club Runner asking for registration. It'll be out a week. It's very important that people sign up and register via the notice. August 29th, Monday, there's no meeting. And then our next virtual meeting will be Monday, September the 12th at noon. So at this time, tomorrow, I want members to know that tomorrow, Tuesday, August the 9th, is International Day of the World's Indigenous Peoples. This is an annual date. And so as you're having your breakfast tomorrow, please reflect on this as you enjoy the day. As I close this meeting, I want you to imagine what the Rotary Club of London can do in the next year. Thank you, and this meeting is adjourned.